evening to everyone. Today we have to discuss the hypothesis testing. So in this hypothesis we have to discuss about what is a hypothesis? Hypothesis is there is a we have to take the any one value. The problem is that often you get a seem to support the idea about the hypothesis. So in this hypothesis we have to discuss about the consequence that can be checked. We can use a count and measure the accept of the nature to check out the ideas. So here one word is hypothesis, nothing but the we have to accept or reject the So here first of all you discuss about the mean. So the mean is nothing but the expected value. So here get the commonly used statistics and expected value. How to use the expected value? The total values all the observations divided by the total number of observations. Here everybody knows that formula is mean is equal to summation fi by summation xi by n. So here the data is and standard deviation. You have to measure the spread of data in standard deviation, and standard deviation is a root of the variance. Here variance is a sigma square and standard deviation is a sigma. The formula for the standard deviation is root of 1 by n summation xi minus x bar whole square. Here we have to calculate the different observations and the mean, and it is squared, and we are all these divided by the sample size. We get the square root, we get the standard deviation. So sample standard deviation means you have to rarely obtain the observations every item in the population. So the estimated sigma is we have to denote it by the S. So the formula of S is root of 1 by n minus 1 summation xi minus x bar whole square. When n minus 1 is called to the degree of freedom and 1 less than number of observations. So here we knowing about the distribution. For example, you have to take the coin toss experiment. We know the formula for the calculating the probability. Any number of heads you have n trials. This can be also known as a binomial distribution. Fortunately, we do not know about the distribution, every situation in the nature. We are saved the central limit theorem. So what is the central limit theorem? The means of the large number of samples drawn randomly from the same population are normally distributed. So this is known as a central limit theorem. So its pair has to use mean and raw, not for the raw data. So here you have to take the sample. This formula is and we have to take the normal distribution. Here we have to discuss about the many observations use the averages of our data. We can draw the valid conclusions because we know there the distribution. So here we have to follow the many test statistics are available in this. We have used the chi-square test. So what is a chi-square test? In this chi-square test, you have to use the expected frequencies and observed frequencies. The expected values into the average results we have to expect it. If the product of the probability items, the number of observations you have to take into the E is equal to P into N. A really useful case in this where the probability of all the cases are equal. For example, you have to take the coin tosses. The probability of getting heads is 1 by 2 and probability of getting tail is 1 by 2. So if for example you toss a coin 24 times, the expected number of heads is 1 by 2 into 24, that is 12 heads. Equal probability cases are usually the basis of the null hypothesis. So what is a null hypothesis? Null hypothesis. First of all, you discuss about the hypothesis. So what is a hypothesis? Hypothesis is any statement of the researcher's idea or guesses. So in this test hypothesis, first you think, write down the statement is called a null hypothesis. In this null hypothesis, we have to assume that your statement is correct. In the null hypothesis, the opposite version is there, that is an alternative hypothesis. So for example, the null hypothesis, you have to take some examples. we denote that there is a no difference in law visibility between the heights and its wages. So there is a no connection between the time since explores of the segments and to the height of the hills of the forms, or there is a no significant difference between the means or standard deviation anything. So in this null hypothesis, we discuss about there is a no significant difference between the average number of stems per square kilometers for the bedrock times. And null hypothesis is denoted by H naught. The another one is alternative hypothesis, and it is denoted by H1. So here we mentioned that there is a significant difference between the values or population means, and the another one is significance value. So here we have to take the significant value. That value is a 5% or 1% level of significance. So in this significance is based on the probability of the particular results. The statistician had to calculate the probability of all possible chances event occurring. So in this many trials use a higher significant level make it is a less likely. The probability of particular results is less than in we have to take the p 0.01. We say the result is significant. That is, the result is not just chance event. For example, you have to take the 1% level of significance. We say the result is highly significant and it is not just chance event. So in this, we have to avoiding the decision errors. So usually we want to avoid the type 1 and type 2 errors. Type 1 error, we will reject the H naught when it is true. Many trials use a higher significant levels, we use a less likely values. And type 2 error means we accept the null hypothesis even it is false. And the another one is test statistics. We often want to see two things are different from each other. In this aspect, there is no difference between the values that there is a null hypothesis, and where is any difference between the values, you have to take the alternative hypothesis. In the test statistics based on the data on your samples, different types of problems require into the different test statistics. The values of comparison to our data has all been put into the statistical tables. So we need to do to calculate our value and comparing it with the value in the table to get out the answer using test statistics. So you have to use the test statistics, observe an unlikely result. We reject the null hypothesis and accept the alternative hypothesis. So for example, you have to say the chi-square significant table. The significant levels are available in chi-square table are usually 5%, that is 0.05, 1%, 0.01, which means there is a respectively in the 5% or 1%. The probability of event occurring by the chances of chi-square obtained. The value of is a tables is called the critical values. So in chi-square test, critical values are used to the test statistic. We have to use a calculator greater than the values in the table. That is nothing but the critical value. We decided to use, you can reject the null hypothesis and accept the alternative hypothesis. So these are chi-square test critical value tables. Here we observe that significant table of chi-square values. These are critical value table. We use examples are given below. For suppose you have to take the degrees of freedom 5%. The 5% level of significance is 11.07 and 1% is 15.09. So in this chi-square test, it is can be only used to observations that have following to the characteristics, objects being counted or independent. The data must be is in the form of frequencies. The frequency data must have a precise numerical values and must have organized into the categorical or groups. The expected frequencies in any one cell of the table must be greater than 5. The total number of observations must be greater than 20. If the observations are less than 5, we have to pool the observations. So in this chi-square test, the chi-square is a false. We cannot use a chi-square. So the test statistics must the situations and they are all similar in their use. Once you have to use a chi-square, you can look up the correct statistics and you have apply it.